Okay, you guessed it. It's time for 2D kinematics. And so in 2D kinematics, the X and the Y parts separate. So essentially you're just doing a 1D kinematic problem twice, where the time is what couples the equations together. So we're still only interested in the case where acceleration is constant. Acceleration is a vector now. Okay. All right, so let's suppose we have a cannon which shoots a cannonball horizontally. So our initial velocity, which is a vector now since we're in 2 dimensions, is 13 meters per second horizontal. Okay. And what we're looking for is how far the ball goes horizontally when it lands. So acceleration in this case is only constant while the ball is in the air. Once it hits the ground, it could bounce or roll or whatever. And in that case, acceleration is not constant. These formulas don't work. So we can only tell what happens while the ball is in the air and the second it hits the ground. So we want to know how long it goes, how far it goes horizontally while it's in the air, or like the moment it hits the ground. And let's say that this cannon is 10 meters off the ground. Okay, well, let's write down everything we know. We want to know how far it goes, so we can just set the initial x position to be 0. Our initial y position is 10 meters, so that's how far it is in the air. Our final y position is 0 meters, because we want to know how far it goes the moment it hits the ground. So we can call the ground 0 meters. Okay. And now we need to decompose this vector into its horizontal and vertical components. Well, that's already done for us. So if we draw our coordinate system here, here's y, here's x, it's already completely horizontal. So it looks like this with a magnitude of 13 meters per second. Now, if we wanted to, we could use our formulas and say that v naught x is our magnitude times cosine of the angle. What's the angle? Well, it's 0. So cosine of 0 is just 1. But we didn't really have to do that, right? Because we can see with our eyes that it's all along the x direction. So the entire magnitude is x, and the y part is 0. So 0 meters per second. Okay, now let's write down the equations that we know. So in the x direction, the acceleration is 0. So our ax is 0. That's just because things fall straight down, right? They don't fall sideways at all. So that limits our x equations. Our distance in the x direction is like this. So we've just left off this acceleration term that we would normally have here. And our velocity in the x direction is just equal to the initial velocity in the x direction. That's because there is no acceleration, so there's nothing to change the velocity, so it stays the same. Now, in the y direction, we have all of the kinematic formulas that we have in 1 dimension. And we can call the acceleration negative g. So this is just the acceleration of things from gravity. Our final velocity in the y direction is our initial minus our acceleration due to gravity times time. And we also have this square one. Okay. And now often what these problems, this is called a projectile motion problem. So this is when we have some object that has at least part of its velocity in the horizontal direction, and the only acceleration is down and due to gravity. So almost always what these types of problems will ask you is how far something goes horizontally until it hits the ground. And so the way to do that is we can solve the y part and figure out how long it takes to hit the ground. and then we can plug that back into our x part, okay? Okay, so which one of these equations should we use? Well, we don't know anything about the final velocity in the y direction, so that rules both of these out. And so we should use this one. From there, we can find the time and then plug it back into the x equation, okay? So y is equal to y naught plus v naught yt minus 1/2 gt squared, okay? And now we'll plug in what we know. So when it hits the ground, it's at 0 meters. It's initially at 10 meters. There is no initial y velocity because it was all horizontal. So this term isn't there. And then we know that g is 9.81 meters per second squared times time squared. Okay. Now we can solve for this. Let's get everything to one side and then take the square root. But remember, anytime you take the square root, there's not just one answer, there are two. You always have positive or negative. So in this case, the time is positive or negative 1.43 seconds. And you have to ask yourself, which one makes sense? Now in this case, the positive makes sense. So obviously the cannonball didn't hit the ground 1.43 seconds before we fired it. So we can say that our time is 1.43 seconds. But that's not what the question asked for. The question asked, how far did it go horizontally in this time? So we plug this into our x equation. Okay, we said that our initial x position was 0. So we just have our initial velocity in the x direction, which was 13 meters per second, times our time, which is this, 1.43 seconds. So if you compute this, you get 18.6 meters. Okay, now we could also find, say, the final velocity in the y direction if we wanted to. We would just plug it back into this equation. So let's do that. Okay, so our initial velocity in the y direction was 0. So we just have this negative 9.81 meters per second squared times our 1.43 seconds. Okay, so if you actually compute that, then you get that our final velocity in the y direction is negative 14.0 meters per second. Now, why is it negative? It's negative because in the y direction, it's falling, and we've called down negative. Okay, but our final velocity is not just one component, it's a full vector, right? So it's the final x velocity in the I direction plus the final y velocity in the y direction. Okay, now what's the final velocity in the x direction? Well, going back to our kinematic equation, our final x velocity is the same as our initial x velocity, which we said was 13 meters per second. So we can write this vector then as 13 meters per second in the I hat direction minus 14 meters per second in the y direction. Now we were given our initial velocity in terms of magnitude and direction with respect to the horizontal. So we can give it back in the same way. So to find the magnitude of this vector, just like we have before, we use Pythagorean theorem and we take the square root of the sum of the squares. So this is 13 meters per second squared plus negative 14 meters per second squared. So if you do that, then you get 19.1 meters per second. And now we need the angle. So here's our horizontal. The y is negative and the x is positive. So we're down here in the fourth quadrant. So our vector looks something like this. So this is our vy part. This is our vx part. And we can find this angle here by taking the arctan of the opposite side, which is the y part, over the adjacent side, which is the x part. So plugging our numbers here, our x part is negative 14, but remember we don't put the negative inside the arctan. So we just have 14 meters per second over 13 meters per second is our x part. And so this is 47.1 degrees. And so our final answer then is that our final velocity right as the cannonball hits the ground is 19.1 meters per second at 47.1 degrees below the horizontal. Now, if you wanted to, you could have also given this angle and said that the final velocity was 19.1 meters per second at 360 minus 47.1. But since our initial velocity was given in terms of the horizontal, we can also just say it's just below the horizontal. Okay, so that's 2D kinematics.